Alright, John, so that's posting to YouTube right now, so let's start doing some of the practice problems that you might see on this test. So I really don't even know why she put this question right after the identities, because none of the identities are even used in this question, but hey, whatever, that's fine. Okay, so if theta is in quadrant 2, and sine theta is equal to 5 over 13, we need to find cosine theta. Okay, so you're going to see a lot of questions like this. Some questions where you not only have to find sine or cosine, you have to find tangent, secant, cosecant, cotangent, all of this stuff. It's really annoying. So here's how we do this. Let's think about this. Sine theta. Now sine we know is from SOHCAHTOA. We know that sine is opposite over hypotenuse. And my pen is just going very slow. I think it's just the computer. There's so much stuff going on. I could get rid of that. Go. Okay. So sine is opposite over hypotenuse. Yes, I would like to quit. Thank you. So we know that the opposite side of a triangle is going to be 5, and we know that the hypotenuse is 13 from the fraction that it gives us in the problem. Now we have to figure out what cosine is. Cosine theta. So cosine is adjacent over hypotenuse. So we already kind of know part of this fraction that we're going to need. We already know that the hypotenuse is 13. But what we need to do is figure out what that adjacent side is. Now we have to be careful just because we're talking about a theta that's in the second quadrant. So while we could just use these values really easily to figure out what the adjacent side is by using the Pythagorean theorem, you have to keep track or remember the fact that we're in the second quadrant. So all students take calculus means that sine is positive in the second quadrant, which is why obviously the fraction right here is positive, but if it's asking for cosine, then that's actually going to be a negative value. So let me do that right now and put a negative right next to our term. Okay, so once you have it negative, you're good to go. So we obviously know that we're dealing with a right triangle right now. We have two sides of the triangle already, the opposite side and the hypotenuse. So we are just going to go through and use the Pythagorean theorem to figure out what that adjacent side is. And obviously you know that it doesn't matter where I put the 5 as long as the 13 is plugged in for C. And this is really slow, so I'm not going to do these two things at the same time anymore. Alright, so we have 5 squared plus, I'm just going to call it x squared, that's what we need to solve for, is equal to 13 squared. Now we can use our calculator, go through. Obviously we know that 5 squared is 25 plus x squared is equal to, I think that's 169. Let me just check. 13 squared. My calculator's freaking out now too. 13 squared. Enter. 169. Okay. 169. And then I need to subtract 25 from that. Sorry. I don't know who that is. I need to subtract 25 from 169. $144. Okay. So if x squared is 144, I want to know what that opposite side is, so I need to take the square root. And the square root of 144 is 12, so x is equal to 12. So that means that the adjacent or the missing side of my triangle is 12. Another way that you could have done that is to just drawn out the triangle to begin with and label what you know and label what you need to find out. And wow, that's a horrible triangle. And that way you can just keep it straight what you're trying to solve for. The reason why I say this is because when we get into harder problems, they're going to be giving you two different values you're going to have to use two different triangles and two different thetas, and it gets a little bit confusing. So you might want to consider drawing out a triangle every time you do a question like this, just to keep things straight. Also, you need to keep track of this to know whether or not the value that you're searching for is going to be positive or negative, okay? So two different things that you need to just be careful of, I guess. Okay. Let's go to the next question. Alright, if cosine theta is equal to 3/5 and theta is an angle that terminates in the fourth quadrant, find the values of the 5 other trig functions. Oh my gosh. Okay. I don't really know why she has two different methods written right here. We never use two different methods, so I'm not really sure. Okay, so the first thing that I want you to do is figure out, alright, we're in the fourth quadrant. So we have all students take calculus. We're down here in the fourth quadrant. So we know that cosine and secant are both going to be positive. Everything else is going to be negative. So what I suggest that you do is come right down here and let's just make a list of all the things that we need to find. So we're going to look for sine theta. We're going to look for cosine theta. Tangent. I'm really sorry that I can't write faster than this. I know it's really annoying. But that's only the first 3 that we need. Those are all going to be fractions. Then we also need, let's see, the reciprocal of sine is cosecant. The reciprocal of cosine is secant. And the reciprocal of tangent is cotangent. Okay, those are going to be fractions as well. And we need to figure out what all 6 of these values are. So these questions are really annoying, but you know what? I think there's at least 1 or 2 of them on the test that you have to take, so you have to be careful. So let's see, we already know that cosine is 3/5. And cosine and secant are both going to be positive because of the quadrant that we're in, but the rest of them are all negative. So just go through right now and put a negative sign next to all of them so that you don't forget to do that later, because it will be wrong if you don't do that. Okay? Now we're going to use the exact same method that we did before. We know that this is the adjacent side because cosine is adjacent over hypotenuse. And this is the hypotenuse. So we need to figure out what the opposite side is over the hypotenuse and then adjacent over opposite. Okay, so we're using SOHCAHTOA. One thing that I would keep in mind, though, when you're doing these, I'm not sure if you ever learned these, you know, in middle school or high school, or I don't even know when you would have learned them, but there's something that we call Pythagorean triples. Now, let me just find this sheet so I can go over it with you. And my cat is laying right on top of my binder, so Parker, excuse me. No, not gonna move. Okay. Sorry, John, 1 second. Alright, I can't find it. Maybe you have it. at home, though. It had a list of all the Pythagorean triples. Let me just do this real quick, if my computer won't freak out. Maybe. Come on, you can do it. Internet? No? Okay, well, there's Pythagorean triples, numbers that, you know, work in the Pythagorean theorem together, and one of the Pythagorean triples is 3, 4, 5. There's, I think, oh gosh, I gotta find them. Oh, now the internet wants to work. Fantastic. Let's Google it. Let's Google Pythagorean triples. Okay. Wikipedia is always so helpful, isn't it? I just want you to be able to have a list of these so that you can write them down, because we had them written in class. Okay, so we have, these are like a lot of them. You do not need to memorize all of these, but 3, 4, 5 is one that you should know. 5, 12, 13 is another one, and 7, 24, 25. Those are all the 3 Pythagorean triples that you need to remember and memorize, just because it'll help you on your quizzes and tests. It'll help you remember and do things a lot faster. The only thing important to remember is obviously the bigger number of the 3 is the hypotenuse. Okay, so in this question it's very helpful, because if we know that 3, 4, 5 is a Pythagorean triple, then I don't even have to use the Pythagorean theorem to go through and figure out what the missing side is. I already know what the missing side is. I already know that we have the adjacent. I know that the opposite side is 4, and the hypotenuse is 5. And then for tangent, we're looking for opposite, so 4 over adjacent, which is 3. Now, how do you think I would figure out what cosecant, secant, and cotangent are? We learned them both today and the other day as reciprocal functions. So if I know what sine, cosine, and tangent are, in order to figure out the other 3, all I have to do is flip it. So in this case, in this problem, it's actually really easy, because they're just integers, they're whole numbers, and we're just flipping them over the fraction. You do need to be careful when you end up with things like radical 3 over 2, because if you flip it and the radical is in the denominator, you have to rationalize that. You can't leave it like that. Okay? So here's the way that problem works. The important part to remember is figuring out which quadrant you're in, so knowing which functions are going to be positive, which functions are going to be negative, going through and listing out everything first, and then either using the Pythagorean theorem to figure out what the missing side is, or you could use a Pythagorean triple. Okay? Let me see how much. About a minute and a half left for this video. Alright, so I'm going to stop here again. I know it's really annoying, and I will post another video for you. Okay?